Gear Patrol calls their new dive watch the best sub-$500 dive watch. Full stop. Men's Health rated them as the most stylish solar watch in the game. Who are we talking about? It's Movement. They're leveling up your gift giving with the sleekest watches you can buy and the biggest deals of the season. Shop 30 to 50% off Movement's innovative California clean watches, jewelry, and accessories with fast free shipping and returns now at mvmt.com. That's mvmt.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 16, for broadcast on the 6th of February 2023. Coming up on SpaceTime, problems with NASA's Juno spacecraft currently orbiting Jupiter. NASA's Perseverance rover completes the Mars Sample Depot, and that green comet we spoke about the other week, well, apparently it's grown an extra tail. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mission managers are evaluating an issue with NASA's Juno spacecraft, which is on an extended mission orbiting the giant gas planet Jupiter. They're trying to determine why the majority of the images taken by the orbiter's JunoCam weren't acquired during last month's Jovian flyby. The data received from the spacecraft indicates that the camera experienced an issue similar to one that occurred on the previous close encounter with the gas giant in December. Back then, mission managers saw an anomalous temperature rise after the camera was powered on in preparation for the flyby. However, the January 22nd flyby saw the same issue persist for far longer, 23 hours, as opposed to just 36 minutes for the December close encounter. This left the first 214 JunoCam images planned for the flyby totally unusable. As with the previous occurrence, once the anomaly that caused the temperature rise cleared, the camera returned to normal operations, and the remaining 44 images were of good quality and quite usable. These were the mission's 47th and 48th flybys of Jupiter. Mission managers say the JunoCam will remain powered on for the time being, and the camera appears to continue to operate nominally. JunoCam is a colour visible light camera designed to capture images of Jupiter's cloud tops. The camera was originally designed to operate in Jupiter's high-energy radiation environment for at least 7 orbits, but as you can see, it seems to have survived an awful lot longer. Juno was launched back on August 5, 2011 from the Cape Canaveral Space Force Station in Florida aboard an Atlas V rocket. The Lockheed Martin-built spacecraft was designed to study the chemical composition of Jupiter's immense atmosphere and cloud tops, peering deep below the obscuring cloud structure to probe convection currents and the deep engines driving its circulation patterns and spectacular surface weather features, cyclonic storms, and iconic salmon and cream-coloured atmospheric bands. Juno is also measuring Jupiter's gravitational field in order to better understand the internal structure of the solar system's largest planet, as well as its magnetic field, its polar magnetosphere, and its auroral activity. Jupiter is the largest planet in the solar system. In fact, other than the Sun, it contains more mass than the entire rest of the solar system combined. So, by better understanding how this Jovian gas giant formed, scientists can learn more about the formation of the rest of the solar system as well. The 3,625 kilogram probe achieved Jovian orbit insertion on July 5, 2016. It's in a highly elongated polar orbit designed to avoid as much of Jupiter's damaging radiation belts as possible. The orbit allows the spacecraft to swoop down and skim just 3,400 kilometres above the swirling Jovian cloud tops, before being taken back out to more than 8.1 million kilometres. To help protect the spacecraft from Jupiter's deadly radiation, Juno's most delicate instruments and control systems are housed in a specially shielded strongbox. Among its early discoveries, Juno gathered information about Jovian lightning, data that forced scientists to revise their earlier theories. It provided the first views of Jupiter's North Pole, as well as providing insights into Jupiter's auroral activity, its magnetic fields, and its tumultuous atmosphere. In 2021, an analysis of the frequency of interplanetary dust particles, primarily on the backs of the solar panels as Juno passed between Earth and the asteroid belt, showed that the dust which causes the zodiacal light comes from Mars rather than from the comets and asteroids which come from the outer solar system, as was previously thought. Juno's also made many discoveries that are challenging existing theories about Jupiter's formation. When Juno flew over the poles of Jupiter, it imaged clusters of stable cyclones that exist there. It found that the magnetosphere of Jupiter is uneven and chaotic. Using its microwave radiometer, Juno found that the salmon and cream bands, which dominate the planet's outer atmosphere, actually extend for hundreds of kilometers deep into the planet's clouds. The interior structure of Jupiter isn't evenly mixed. This has resulted in the hypothesis that Jupiter doesn't have a solid core as previously thought, but a fuzzy core made out of bits of rock and metallic hydrogen. This unusual core structure may be the result of a collision that happened early in Jupiter's formation. The original plans called for a total of 37 orbits around the 143,000 kilometre wide planet, with the original 53.4 Earth day polar orbits eventually contracting down to just 14 Earth days. However, those plans were scrapped following ongoing concerns about the spacecraft's main engine, meaning that all orbits remained at 53.4 Earth days, which would have meant fewer orbits overall. The good news is that Juno's coped with Jupiter's extreme radiation belts better than expected, and that's allowed its current extended mission to proceed. By extending the mission, not only were those missing orbits included, but lots of additional orbits were also added, allowing greater exploration. Juno will make its 49th pass of Jupiter on March 1st. This report from NASA TV.
Jupiter's by far the largest planet in the solar system. It has an influence on everything else. So if we want to understand how do planets form, how do solar systems form, we really have to start with Jupiter.
By studying Jupiter, you're going to get one piece of the puzzle, not necessarily how life formed, but maybe how the ingredients that made up life eventually got spread around in the early solar system and got to us.
We care about the light elements because that's what we're made out of. We've got a puzzle about where these volatile elements, these lightweight elements like nitrogen, carbon, noble gases, where they came from.
To determine how much water is in Jupiter is essential to understand how this planet came to form and then how it influenced the formation of all the other planets in the system.
When the Earth formed, in the absence of Jupiter, it probably would have gathered very little water and organic molecules, which would have been concentrated in the colder outer part of the solar system. What Jupiter evidently did as it formed was to scatter cold material that contained water ice and organic materials to the inner solar system, where it could be captured by the Earth and the other terrestrial planets.
We learn about the origin of the solar system. We're learning about our own origins. We're learning about how life comes to be, about who we are and what our place is in the universe. It's about knowledge and about humanity's quest to understand. For me, that's why we need to study Jupiter and the solar system and almost everything.
And in that report from NASA TV, we heard from Juno project scientist Steve Levin from NASA's Jet Propulsion Laboratory in Pasadena, California. Juno principal investigator Scott Bolton from the Southwest Research Institute in San Antonio, Texas. Juno atmospheric science investigator Andy Ingersoll from Caltech. Planetary formation investigator Tristan Gouliot from the Côte d'Azur Observatory in France. And planetary formation investigator Jonathan Lewin from the University of Arizona. This is SpaceTime. Still to come, NASA's Mars Perseverance rover completes construction of the Martian Sample Depot and will explain the green comet's extra tail. All that and more still to come on SpaceTime.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you, Fargo? You can in the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
NASA's Mars Perseverance rover has now completed its construction of the Mars Sample Depot on the surface of the red planet. 10 sample tubes containing an amazing variety of Martian geology samples have now been deposited on the Martian surface, thereby providing a backup to the 10 identical samples in the cache aboard the Mars Perseverance rover, which are destined for eventual transport back to Earth. Less than 6 weeks after beginning setting up the sample depot, the 10 samples were carefully positioned on the Martian soil. Throughout its science campaigns, the 6-wheeled car-sized rover has been collecting pairs of samples from rocks which mission managers deemed scientifically significant. One sample from each pair now sits in a carefully arranged depot in the Three Forks region of Jezero Crater. Now, this project wasn't just a case of dumping a bunch of metal containers onto the ground. The titanium tubes were placed in an intricate zigzag pattern with each sample between 5 and 15 meters from the next. Each had to be carefully positioned so that they didn't block access to any of the other samples, and the exact coordinates of each, together with the correct glove adapter combination, needed to be carefully recorded so that future mission managers knew exactly where to look and how to safely recover them if needed, either by means of another rover on the ground or by a rotocopter from the air. These depot samples will serve as a backup set, while the other half remain inside Perseverance's cache, which will be the primary means of conveying the samples to a sample retrieval lander as part of the sample return campaign. Mission scientists believe the igneous and sedimentary rock cores provide an excellent cross-section of the geological processes that took place in Jezero shortly after the crater's formation 4 billion years ago. The rover also deposited an atmospheric sample and what scientists call a witness tube, which is used to determine if the samples being collected have been contaminated with material that's travelled with the rover from Earth. The depot is located on flat ground, not far from the base of a raised fan-shaped ancient river delta that formed long ago when a stream flowed into the lake. Perseverance's Deputy Project Manager Rick Welsh from NASA's Jet Propulsion Laboratory in Pasadena, California, says now with the Three Forks Depot in their rearview mirror, Perseverance can now head up the delta. The rover will make its ascent up through the Hawksbill Gap previously explored. Once past their geologic unit the science team calls Rocky Top, it'll be in new unexplored territory and begin studying the delta top. Passing the Rocky Top outcrop represents the end of the rover's Delta Front campaign and the beginning of the rover's Delta Top campaign because of the geologic transition that takes place at that level. Perseverance project scientist Ken Farley from Caltech says that from the base of the delta up to the level where Rocky Top's located, the rocks appear to have been deposited in a lake environment, and those above Rocky Top appear to have been created in or near the end of the Martian River flowing into the lake. As Perseverance ascends the delta into the river setting, scientists expect to move into rocks that are composed of larger grains, from sand to large boulders. And these materials are likely to have originated in rocks outside of Jezero Crater, where they were eroded and eventually washed down into the crater as river sediment. One of the first stops the rover will make during the new science campaign is at a location mission managers are calling the Cavilla-Near Unit. Essentially a Martian sandbar, the unit's made up of sediment that eons ago was deposited in the bend of one of Jezero's inflowing river channels. The science team believes the Cavilla-Near Unit will be an excellent location to hunt for intriguing outcrops of sandstone, perhaps mudstone, and it might even get a glimpse of the geological processes taking place beyond the walls of the crater. Of course, the key objective of Perseverance's mission on Mars is astrobiology, including searching for samples that may contain signs of ancient microbial life. And a river delta region with nutrients and lots of water is a great place to look. The rover's also characterizing the planet's geology and past climate, paving the way for human exploration of the red planet sometime in the next decade. This is SpaceTime. Still to come, the green comet grows an extra tail. We'll explain how that happens. And later in the science report, the hunt continues for a missing shipment of radioactive cesium-137, which quite literally fell off the back of a truck in Western Australia. It's a truly amazing story. All that and more still to come on SpaceTime. A couple of weeks ago, we reported on a spectacular green comet, C2022E16, which has just streaked past the Earth and is now back on its way to the dark outer reaches of our solar system. The comet was clearly visible in dark skies away from city lights, providing sky watchers with a spectacular sight. Originating in the distant Oort cloud, possibly more than a light year away, the green comet takes over 55,000 years to complete its orbit, meaning it last visited the inner solar system when Earth was still in the Stone Age and Neanderthals roamed Europe and Central Asia. The Oort cloud is a hypothetical sphere of comets, icy debris and frozen worlds, some possibly from other star systems or interstellar space, which are being caught up in the sun's gravitational pull and are now following the solar system as it orbits around the galaxy. The greenish tinge on the comet comes from chemical reactions as various volatile particles vaporize off into space from deep inside the comet. But what's made it especially interesting for now is that in addition to its fully formed coma and twin tails, C2022E3ZTF also appears to display a third, so-called anti-tail. This bizarre third tail is made up of the same material as the comet's other two tails, one made of dust which is blown off the comet by the solar wind, and the other made of gas and ionized particles from within the comet itself that sublimate directly from solid cometary material. These twin tails are clearly visible. The dust tail reflects sunlight, while the gas within the other tail becomes ionized, giving off a faint glow. Eventually, this released gas cools and becomes invisible. But the leftover dust is left to drift in the comet's wake as it makes its way around the sun. And that's where the anti-tail comes in. See, it's not actually part of the comet itself, but it's an optical illusion caused by the Earth passing through the comet's orbital plane. And that causes some of this dust to be re-illuminated by the sun, appearing as a bright streak, which can look like it's streaming out of the comet in the opposite direction to its tails, depending on the comet's trajectory and orientation. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Well, the big question today is how does a radioactive shipment of cesium-137 just quite literally fall off the back of a truck? The cesium-137 was inside a tiny 6x8mm button-sized silver pellet, smaller than a 5-cent coin. It was fitted inside a radioactive gauge and stowed in a large lead-lined radiation casing, bolted into a special transportation pallet which had been loaded onto the truck. Hazmat teams and emergency services have been scouring some 1,400 kilometres of Highway 95 between the Rio Tinto mine at Newman in the Western Australian Pilbara and the state's capital of Perth looking for the pellet. Cesium-137 is commonly used in mining operations to detect the flow of liquid through pipes, to measure the thickness of materials, and, as in this case, reportedly for calibrating radiation gauges. West Australian government authorities claim the pellet was in its transport container when it departed the mine. But the cesium-137 pellets, together with some screws and a bolt from the gauge, were not there when the container was checked sometime after its arrival at the depot near Perth. Authorities say they don't believe the radioactive pellet was stolen or deliberately removed. Instead, they're speculating the constant vibration of the moving truck caused the gauge to shake loose inside the container during the trip. That resulted in the pellet, some screws and a bolt falling out through the hole left by the bolt and onto the deck at the back of the truck, before eventually rolling off onto the road. No explanation how it came out of the container, however. And that raises some serious questions about the radiation security of the container, which is being used for the transport by Rio Tinto. The current fear is that the radioactive pellets fallen on the road and then became wedged in the tyre tread of another vehicle, which means it could be anywhere right now. Cesium-137 emits both beta radiation, which are basically free-flying electrons and positrons, as well as high-energy photons in the form of gamma radiation. While the beta radiation will be blocked by the shell of the capsule, the gamma radiation will stream right through it, delivering some 662 kiloelectron volts of energy. The source has an activity of 19 gigabecquerels, which means it's emitting about 19 billion high-energy photons every second. The cesium-137 ceramic source, commonly used in radiation gauges, emits some 2 millisieverts of radiation an hour. That's the equivalent of 10 chest x-rays an hour. The authorities warn that if you happen to find the pellet, you should stay at least 5 metres away from it. Western Australia's Department of Fire and Emergency Services says while the capsule could not be weaponised, it could cause acute sickness, radiation burns, and other long-term risks such as cancer. Cesium-137 has a half-life of over 30 years. That means the capsule itself will remain somewhat radioactive for at least the next 300 years. A new study warns that people are breathing in airborne microplastics even when they're in their homes. The findings, reported in the Journal of Environmental Science and Technology, show that you're likely to be exposed to thousands of airborne microplastics every year, and that would primarily be indoors. The study investigated the abundance, distribution, form, and possible sources of microplastics in both indoor and outdoor sites, finding concentrations are between 1 and 28 times higher indoors. Now, with people spending approximately 90% of their time indoors, and based on the indoor to outdoor microplastic levels identified in the study, the researchers calculate that the average human would be breathing in some 2,675 airborne microplastic particles every year. Bit of good news now, and a new study claims a latte could have some anti-inflammatory effects in humans. Scientists from the University of Copenhagen say a combination of proteins and antioxidants found in coffee with milk seems to double the anti-inflammatory properties in immune cells. Whenever bacteria, viruses, and other foreign substances enter your body, your immune system reacts by deploying white blood cells and chemical substances to protect you. The reaction, commonly known as inflammation, also occurs when you overload tendons and muscles, and is characteristic of diseases like rheumatoid arthritis. Antioxidants, known as polyphenols, are found in humans as well as plants, including fruits and vegetables. Now, in their study, the researchers investigated how polyphenols behave when combined with amino acids, the building blocks of proteins. Their findings, reported in the Journal of Agricultural and Food Chemistry, show that polyphenols react with amino acids, causing an enhanced inhibitory effect on inflammation in immune cells. The authors observed that immune cells treated with a combination of polyphenols and amino acids were twice as effective in fighting inflammation as cells which had only had polyphenols added to them. A baby in New Zealand has been placed in his doctor's care after his parents refused to consent for a blood transfusion unless the hospital could prove that the blood hadn't come from a donor who had been vaccinated against COVID-19. Tim Mendham from Australian Skeptics says New Zealand's blood service has received growing calls from anti-vaxxers demanding non-vaccinated blood.
There have been a couple of cases recently of parents of young babies refusing or preferring not to give transfusions to their babies for surgery unless the blood is proved to be unvaccinated. The fear they claim is that vaccinated blood gives off COVID or anything else that can affect their child. Now, there was one particular case which got a lot of publicity of a 6-month-old baby. The parents sort of refused to have vaccinated blood transfusion. The doctors took it to court and the court gave temporary guardianship to the doctors and surgeons and things, who then performed what was urgent surgery. It had to be done in the next day or so. So there was no time to mess around trying to find unvaccinated blood. Not that the blood is actually classified that way by the blood banks. Anyway, so the surgery happened. It was fine. It happened. But it's not the only one. There's been, as I said, a second one about a week later in New Zealand was doing the same thing. They refused to sort of sit around and get guardianship. They were going to take their baby to India, where they would get safe blood, in quotes. I don't know if India's the place to do that, whatever. But yeah, they were flying overseas to try and find a place where they could get unvaccinated blood. And apparently this has been a thing that's been going on at least for a lot of 2022. Around the world, various places, people have been asking for unvaccinated blood, even though there is no scientific evidence that vaccinated blood is dangerous to pass on any sort of COVID-related diseases. It's a strange phenomenon. It's just part of the anti-vax movement. It's part of the hysteria and scare tactics that have been promoted by the anti-vaxxers on any particular thing they can name. Of course, lately the trend has been blaming deaths of famous people on their being vaccinated, basically creating anyone who died recently, saying, see, vaccination. That's the trouble. The vast majority of people are vaccinated. So trying to find unvaccinated blood for a start is difficult. There's an ethical issue about what's called distributive justice, I think it is, where you can only go so far in demanding your rights, and then you start interfering with the ability of the system, if you like, to look after everybody equally. So if you're saying you have to have unvaccinated blood and you send the hospital blood bank scurrying around trying to find it, it's basically taking resources away from other people. So you can go so far in your rights, in quotes, but not to the effect of actually harming other people.
I think it was a big thing not all that long ago of people actually stockpiling their own blood supplies to make sure it's pure for future use.
That's right. There were also cases of people stockpiling their blood in case they caught HIV later on and had to be tested to see if they could participate in social activities or sport or that sort of thing.
The fact that you're vaccinated, all that's doing is teaching your body how to make the antibodies needed, and the original vaccination material disappears in a couple of days anyway.
That's right. It's not a live virus that's being injected into you.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.